So colloids. A colloid or a colloidal dispersion is a mixture in which you don't have a solute per se. The substance that's dissolved is finely divided, but it's larger than typical solute particles. It will not settle out, it will stay suspended, but it will diffract light. So here's soap in water, and we see it's got sort of a cloudy appearance. That's not a precipitate. A precipitate would eventually fall out of solution. This is going to stay cloudy because those particles are small enough that they'll stay suspended. Gravity's not going to pull them down, but they're larger than the water molecules significantly. So colloidal particles, typically a nanometer to 1,000 nanometers. Under a microscope, colloidal particles have a distinctive jittery motion. It's called Brownian motion. And it's caused by the water molecules bumping into these particles. Colloidal particles are large enough that they can be seen under a microscope. And so you can watch them, and they jiggle around. It's called Brownian motion. Got this video. Pollen grains. So you see how they're wiggling? They almost look like little living organisms, right? They're not alive. That was short. So that's Brownian motion, that jittery motion. And that was an early indication that there were particles moving. I don't know what I've got going on here. Something funny with the screen. Anyway, we mentioned soap in a previous chapter. When you add enough soap to water, you get micelles. And here's a nicer picture than I drew the other day. Micelles of soap. And so the nonpolar tails hang out together because they don't like the water, and the polar heads of the soap molecules sort of circle the wagons and go on the outside. And so it can dissolve grease or oils because the grease gets inside here, and then it's like, being transported away by these micelles. These form suspensions. They're significantly bigger than the water molecules, but because they have electrostatic repulsions between them, they're not going to come together and form one big layer or anything. They're going to stay separate macromolecules. Oh, there we go. There are colloidal dispersions found in many different places. Fog is a dispersion. Smoke, which is a solid in air. Whipped cream. Milk. The fat globules are the colloidal particles. And you can also see solid emulsions. An opal is silica glass that has water suspended in it. And that's what gives it its pretty appearance. The Tyndall effects allows us to distinguish between a colloid and a solution. If a colloid is dilute, you might not be able to see the cloudiness. But if you shine a strong beam of light through it, you can see the light beam in a colloid, and in a solution you cannot. The same effect happens when the windows let in sunlight and you see the rays of the sun in the air. It's because there's dust in the air, and the dust is reflecting the light, and so you can see the sunbeams.